Yes, we are complete. So let's start. Since we already had a volunteer last time, Mr. Schwarz, then the question is just which function would our volunteer like to implement. On our menu we would have a trim function that trims a string from either both ends or just one of the ends, depending on what is specified. And trimming normally means that it will remove spaces from both ends. But it might also mean that it not only removes spaces, but all characters which counts as white spaces, so space, tabulator, carriage return, and new line. And to make the function more exciting, I was thinking that we could just specify a string with arbitrary characters which we want to trim from either end. So the function would take a flag that says whether it should trim from the left, trim from the right, or from both sides, and then it would take a string which by default would just contain one space, but which could contain arbitrary characters. So that would be one option to one thing we could implement. The next thing we could implement would be the two upper and two lower functions. So functions which will convert the content of a string either to all uppercase or to all lowercase. And the next thing which is also useful with strings is a function which computes a sort of hash value of the string, so something that is short enough to fit in a register, and is as uniquely identifying a string as possible given the significant reduction in available data space. So the idea with such hashes is, for example, if you want efficiently and quickly compare a lot of, so like one input string against a list of known strings which are long enough that you think that improving on this would be a significant computational advantage. And then what you do is you calculate the hash value for the string. You know already the hash values for your other strings you want to compare it to, and then first you just compare the hash values, and only if the hash value match, then you proceed to actually comparing the entire string. Because of course, if you have a string of 10 or 20 or arbitrarily many more characters, if you represent this with a 32-bit or a 64-bit number, then you will have a lot of repetitions, so that the hash values will definitely not be unique. And in many applications, it's really also even enough to have a 16-bit hash value. So here we would target it for 32-bit. Yeah, and as said, this improves usually such comparisons a lot, because then you really just compare one single 32-bit value, and only if this matches, you really then go to compare the string character by character for all its length. Another thing I think these are the things we would want to implement today, which are all not completely trivial. Other things we might look into today, if we have only 15 minutes left, would be to improve our find function to allow it to work with wildcards. Wildcards means that if you specify an asterisk, then at this place of the string you can have an arbitrary number of arbitrary characters, and only the next character after the asterisk has then to match again. And if you specify a question mark, then it means only one random character is allowed at this position. And last thing, which might be interesting, would be to implement something to convert strings from character to white character and back. But that would be something for the next lecture, if we have a next lecture. So since we missed one lecture when I was sick last month, I would make one additional lecture next week, despite the fact that technically next week should be no more lectures. So if anyone wants to join, you are welcome, but it's not mandatory. Okay, so I would say let's start. So which of these three functions would you like to do? Okay. Is it working? It should be working. Yeah, the IP address changed. Moment. This is somewhat very random whether it changes or not. Because technically it should be a 13-day lease. So if we have one lecture every week, it should be fine, so that it does not go away, but sometimes for some reason it decides to reset it. VNC CPP. Okay, try again. Yes. So the external IP should not change. Just the LAN IPs are changing, and then I need to redo the port forwarding. I mean, I could just give a static IP to the virtual machine, but it kind of usually was not necessary. It should return a new string. Most string functions are designed such that they don't change the existing string, just return a new copy. The only prominent exception I know is the replace function in Qt. For some reason they decided to make it change the actual string it's executed on. Generally, I guess it's just intended as an optimization, so to avoid to reallocate new memory each time for a new string if you have like multiple replacements after each other, because that's a common use case. But it's not what one would expect, and might cause issues, because normally you expect your original string to stay unchanged and then you do something with it and then just get new copies each time. But with Qt that's different, so that's one thing to be careful about. Now we would want to have left or right or both. So the best would be a bit flag. 1 is left, 2 is right, 3 is both, obviously. Ideally, we should define an enum for that, because then it's for user friendly for the user. The user then knows what the function will do. I would define also both, such that the user sees which options he has. Also, the compiler will not allow you to specify the number free. You would then always need to cast to trim mode. So having the both also defined. Yeah. Well, I would still use 1 and 2 for left and right, because then you can easier check just by checking whether a bit is set from which end you want to do. Saves like 2 or 3 CPU cycles. Yes, then it should be fine. Normally default would be both. So the function can take the string value of the current string, so we don't need the first argument, or you can repurpose the first argument to be the list of characters which you want to remove. I would. I guess const character is easier. I mean, it's more computationally efficient. Why? If you make const character, you have. Yes, exactly. to trim. Hmm. There is maybe one downside to using char. I guess we cannot specify a default. I'm not sure if the compiler would take a normal C string as a default parameter. I mean, but I think it should. Why wouldn't it? Let's just try, yeah? Is it complaining? No, it's not. That test might not work since it's a template. If you don't call the function, it will not really be created and compiled. That's a catch with templates that if you write something, it might look fine until you try to use it. Hmm. Hmm. The copy and the copy failed. Does it work when you try it locally, or is that just a VNC thing? Yeah, I also use it often, but it should be working, but somehow apparently. I mean, it is strange. My experience with VNC is that it works from all the remote desktop tools best with regard to not messing up key sequences. Like when you use Microsoft Remote Desktop, then all the Windows key combinations not even work, which is a terrible design. Because if you do Windows something, then that is always on the host. While VNC really captures all keystrokes except F8, such that you have an option to bug out into the menu. Um, yeah. Mm-hmm. We have substring, we have find, we have uh, a lot. Well, what you would need was to would be a find function which is pretty much implemented like find first, not off. Because what you want is something that is not within your trim string. And in fact, STL implementation of string has this, if I remember correctly, first find not off. And of course, Qt has also this function, so this is something useful. But that would be a thing you could implement, such a new find function, which works on this premise that it searches the first character which is not has not been passed to it. Yes. Mhm. Mhm. Mm-hmm. We had a function, I think it was called length. Yes. Well, 0 would be a good candidate since the first character is not out of the set, so that could be a good approach. Ah, you mean if there is no, if you don't find anything, yeah, then return the length of the string. That would be the null character technically is uh, not part of your set, so that would be probably a good solution. It would be consistent with what behavior would be expected. Mm-hmm. Mm-hmm. What do you mean? You can just plus the pointer, then it moves to the next character. Ah, in our function. Did we implement the add function? Yes, we have the bracket operator, so that should work just fine. Mm-hmm. Yeah. Well, then we have just to go to the next one. So mhm. Probably it would be better within the loop. If they are not equal, then you just return the current index and you're done. Why? Yeah, but if we find true, of course, yes. Um, I think you will need one. Well, no, you can check. Yeah, exactly. You can check pointer. If we checked all of them and did not find, yeah. We are missing in the incrementation of pointer. We'll be checking the same character forever. Mm-hmm. Yes. Yes. Uh, well, you could expect it to wrap around, and then to check for your condition that I is not equals -1, because -1 evaluates to the max value, and if you do a minus minus on 0, you will get max value in your I. You should not need to cast it. It should just accept -1 as is. Mm-hmm. Should be working. We will see. um. Then you return -1 basically. Well, or you still return the length. Last not off. I mean, when you use the functions, then you can decide which you would prefer as a indicator to not do anything. So just let's stick with -1 for now, and then we'll see whether we might want to change that later on. Mm-hmm. Yeah. Well, you could have defined endpos as just length without the -1, like the position of the end character, which is null, which is length +1. Which is just at the value of length as an index. And then you can just check if start and stop is the same, then there is nothing in the string. Yes. Then we just return an empty string. Yes. Mm-hmm. If we say that the end pos should be just length, so we would need to remove the -1 at line 262. Then it should just be end pos without minus start pos without +1, I think. Mm, well, that depends how long the string is, right? So if start pos is 0 and end pos is 1, yeah, try it out. Mm-hmm. Yeah. Mm-hmm. Why? This is vchar. You need to use t. Mm, t asterisk just. That will be in a few places. To trim. Yeah. Uh, uh, yeah. Mm-hmm. It needs to be const. Mm-hmm. You can print some characters before and after, like square brackets, for example. That seemed to work. Now we need to check the edge cases where we don't have anything in the string. Hmm? Maybe also the edge case where you only have something on the left or on the right, and the edge case where you have just spaces inside. That's a good test case. Okay. Mm-hmm. Up to G. Okay. And the other way around. Okay, seems to be working fine. Yeah. Okay. Yay, perfect. Very good. Yeah, yeah, would be good to test. The flags must work. That's so straightforward that I don't expect it to be able to be able to not work. So that I guess we don't need to. And then we have left or right. Ah, that might not work. Let's try it. Yeah, let's try just trim left. You need to access by cx string double point, and then you can directly specify already the enum name. You don't need to specify the enum type. Mm-hmm. Yeah. And we should add some text to it, maybe. Actually, we just should retest all the test cases line 88 till 93 with left or right. So maybe instead of adding new lines, we could just add yeah. Test for all the lines. Yeah, okay, we start with line 1 and then we see where we go from there. Okay. Wait, that's the right count of spaces? 1, 2. 1, 2. Okay. Then right. It's blocked because it's something marked. Press escape or yeah. It looks right as well. Mm-hmm. We could try one of the commented outlines. So if yeah, or multiple characters. If this works. It was right, yeah, or both. Mm-hmm. Mm-hmm. Seems to be working fine. Good. Yeah. The next one was to upper and to lower. It should return a new copy, yes. What do you mean if there is no lowercase? True. But we cannot know this without checking the whole string. Yes. Get is internal to get the SX string. Yes. No. But you can. We have a constructor that takes the buffer and the length, so you can get your struct and then just use the data and length arguments from it to feed it to a constructor. I wouldn't call it result because that will be the current data or something like that. Struct, yeah. Uh, yeah, for example. Yes. Well, the cheapest way to construct a result string is just you write cx strength from t result is equals asterisk this, and it will do internally pretty much the same thing. Just get the struct and pass it to the copy constructor. So just write cx string from t result is equals asterisk this. You can make it even in one line. Is equals asterisk this. Sternchen this. And you have your copy. Well, technically it will do the copy once you first use the the index operator, but that's good enough. Actually, there is a way to improve that. If you make, because what you want is to check whether the character is lowercase, and then you want to do something to it, right? So if you would use the const version of the index operator on the result array, then you would not make a copy. Only once you decide to change one of the values, only then you would make the full copy. So that would be and optimization. I would work here. Why would we want a second helper function? Um, I don't think it would have any benefit. Mm-hmm. Uh, that is... yeah. Well, the problem with the umlaute is that you will have different umlaute whether it's a normal string or whether it's a Unicode string, I guess. I'm not sure how they represent the umlaut, if they actually use the umlaut values from the Latin 1 charset, or if they actually represent the umlaut as a white character. I would just say let's stick to English. But I guess if you have a function to upper and to lower, like provided by the Qt framework, they will use some localization and other settings to decide what to do with such characters. I can test it actually really quick. Mm-hmm. Okay. Then show the code again. Probably. Yes. That's it. So okay, then the other way around. Ah, it's already done. Okay. That's embarrassing. Uh, I made a quick test case for Qt, so we want ABC umlauts and then to upper, and it just returns garbage. So Qt screwed that up royally. I can check when I initialize the string with a right character array whether that will actually behave better, but string from char array, it probably will. We will see. Okay, let's run. Running. Okay, it's compiling. And okay, so if it's initialized with Unicode values, it works correctly, but if it's initialized with ASCII values, it just returns garbage. Okay, let's try that. I added the sharp SS. We will see. It replaced it with two S's, two capital S's. Okay, interesting. Yeah, but it's still terrible that it completely failed when initialized just with a non-Unicode string. Because normally you would expect this for at least the Latin 1 character set to work correctly. Okay, so what did it do? It just made... Oh, it actually does not load them from the string at all correctly, so it's not a problem with to upper, but the problem that when you initialize it from something that's Latin 1. Okay, but then we should try to do it correctly. Let's try qbyte array qstring qstring from Latin 1. Okay, and let's put this into another test variable just to be on the safe side. Test1. Because the byte array is like really just the bytes. So we can use it for binary data of any sort. While the string is optimized for string, it uses a Q char type and etc. etc. So it's much more sophisticated. So we first can check whether the data within the byte array is okay, which it is. When we then go from Latin 1, then it does it correctly, and then if we try, then it actually works. So it seems that just the initialization of QString from a normal character string, a normal C string fails for non-Latin 1 characters, but if we use the conversion function and tell it which code page to expect, then it works fine. Well, okay. Good, but with our thing is also working within our constraints well. Okay, so I guess we need another function and maybe another volunteer. Maybe Mr. Leo. And where are we? Well, reverse string sounds easy. But maybe reverse string and add wildcard to our find function. That would be a good good task. Yes? Yes. Mm-hmm. Mm-hmm. Well, the best would be if you just initialize it without copying, because the copying is a useless operation in this case. We have a constructor, I think. Wait, check which constructors we have. Don't we have one that takes a length without anything? And if we don't, then we need to add it. Let's see, at the very top. Well, we could improve yeah. So we can change the constructor that starts in line 18 such that if p string is empty, it skips the copying step. Hmm. If it's not null, we want if it's not empty. So if it's not null, then it's fine. Yeah, that's pretty much it. Null should be just fine. Yeah. Mm-hmm. I guess you forgot the semicolon. Uh, something went terribly wrong. Can you show what the output to the console was? That's the wrong one. This one. Yeah, interesting. So the input string is already wrong. Can you show me the code again for reversing? Wait, this. Yeah, the other one. Wait, that. The first one should be right. That's true. Why is my string not working? Interesting. Go with the call stack to where it comes from, so that we see where the problem originates. Bottom right. Yeah, this. Click. Ah, haha. That's the problem. Wait. That's not a. That is a problem, but why does this happen? Why wouldn't they? Yes. But this was null. Only length is. You need to change the something in line 20. So there, if length is -1, but length should not be -1 in our use case. Okay, let me have the mouse. We have screwed something up. So the problem, what happens is that it here just computes some far too large length, and then it tries to write to the offset which it does not have. But the question is why. Let me fill this with 10. We start with a string null and length. So we start with length, which is fine. But then it should not use this function. Then it creates with length. But apparently length is not a valid offset. At length. Create should do a +1 to our length. Create takes length. Well, it allocates. It doesn't return the null, so a character. But this here allocates one more character, so we should have enough room in data. Let's quickly step through that. Why is that failing? So we get in. We do this to get length. Yes, then again, so we end up here. So this is null. This is 10. Then we go here. We go to create. We set length. We allocate one more so that we have the terminating null. We set those things. Then here we. The check is wrong. It should be is equals. Wait. Yeah, it should be if it's not null. So if it's. That's the bug. The thing seems to be that we then. It's a good question why the error bugs out in the next line, but this is where the problem starts. Now it should work fine. Don't need the breakpoint. Suck. That looks correct. Good. That was easy. That was too easy. The next thing is the Dingsbum star. The extension to allow wildcards in the find function. Well, if there is, then that's an opportunity to fix it. Both of them. You can make a new one. You can write one that's called wildfind, because in principle we would want to specify whether we want wildcards or not. So we would either need to add an additional parameter to find, or we just make a second find function which does not, which just always assumes that it will look using the wildcard semantics. Yeah, why not? Normally you have a different one. Qt is, for example, is a bit particular that they have just find function and it takes either a string, which is in a normal find, or it takes a qregex, which then can be a whole regular expression. Although with Qt regular expressions you can configure them such that they will actually work with the wildcard syntax. Although that's only true for the Qt5 regex. In Qt6 they removed the QRegex class and are just offering the QRegulaExpression class, which cannot be configured to use wildcards, but it offers you a function that takes a wildcard expression and converts it to a valid regular expression that would behave the same way. So they made a few things complicated. But Qt is, well, not everything must be done the way they did it. So I think having a own function is fine. I'm thinking if other frameworks have something like so. STL doesn't have such specialized functions. MFC also not. I think the wildcard find is really something that people have to implement themselves if they need it, and then it's a separate function anyways. Okay. So an asterisk means an arbitrary amount of random characters, and a question mark means one random character. So what you need to do as soon as you encounter an asterisk is to check what is the next character after the asterisk, and then see if in the remaining string this next character somewhere occurs, and then skip the whole string section, go to that index, and then continue from there. And of course you need a special case handling in case some programmer decided to write two asterisks after each other, which it would be completely unnecessary. Yeah. Arbitrary many. So it's pretty just a random string you are looking for, and if you don't know a part of the string, you replace the part you don't know with an asterisk. And you can have many asterisks. So you can have, if you know that you are looking for something that starts with get, then you have asterisk, then I don't know, you have length, and then you have another asterisk because it could end with in bytes or with nothing. Oh, and one more thing, asterisk is also valid for if there is nothing more. So it can be also null. So it can represent an empty string. It's just really anything can be there, including nothing. So for example, if you would use wild asterisk to match wild find, it would match correctly, despite the fact that there is nothing following after it. Ja, genau, Sternchen. Mhm. I mean, I would do it without it, but if you have a plan, then go ahead. The simplest approach is just start, and then when you encounter an asterisk, then you deal with it. It's not necessary to know ahead how many there are. Yes, you can use the you need to count the length unless you would be using a CX string as input, then you get the length from our struct reference. Mhm. Yeah, you need C. Yes. That should work just fine as long as you use non-Unicode characters. So, since the value of the white characters for the ASCII portion of the character set is the exact same, it will match if you compare like this, whether we are using chars or white chars. Hmm. Exactly one. Well, and then you have the else case when it's not a wildcard but a normal character. No, so if you encounter a question mark, you can just continue because you match whatever there is. If you encounter a normal character, then you need to check whether the character is what is expected to be there in the string. Well, you can check how the other find function works. You need basically two indices. One that denotes the start from where you are looking right now, and one which then makes the matching. And if the matching fails, then you move ahead by one and then try to match again, and then you repeat that as long as you repeat it until you find something or until the string is done. So one you already have, it's your I. Well, no, not really. You need a whole loop around the current loop you are in right now. You need a loop that would go from your start position towards the end of the string, and then inside that you would use the second loop to match the substring. If it's successful, then you return it, and if it's not successful, then you need to exit the inner loop, increment the outer loop by one, and then try to search again. No, so let me write down some examples how this should work. So um, let's say we have a string blah bloop 1, 2, 3 test. So if you would try to match it with blah stern test. So if you would look for this string, you make find string this, then okay, we need more. 1, 2, 1, 2, 3, 5, 6, 7, 8. Okay. So then what it would return would be so if this is our match case, then it returns index 4 because we have blah. So it starts at blah. So we return so we have like 0, 1, 2, 3, 4. So it returns 4. And it checks blah. Okay, then we have the asterisk. So bloop is fine, everything is fine. It checks basically whether there is somewhere the thing that comes after the asterisk. And of course, the way it's made, it can also have multiple asterisks. So you can have test, and then you can have let's say 5. So then it would try to match this portion of the string and would still return you the 4. If you, for example, make test asterisk 5, then it would return you wherever this is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I think it's 17. Then it would return you 17. If you would look for this one, bloop, that would return you also the index of bloop. So 1, 2, 3, 4, 5, 6, 7, 8. The idea basically is that if you don't know a portion of a string, you just know some parts of it. You can specify the parts you know, specify an asterisk for the parts you don't know, and then it will give you wherever this string expression starts as a offset. So obviously something like say test asterisk is pretty much the same as you would just search for test, because we don't specify that the string needs to end. So this is basically meaningless. A tailing asterisk can always be ignored in this find function. And if we have an asterisk at the beginning, that's pretty much useless because that would always return you 0. Because the string starts with something, and then if it finds test, then it will return you 0, or if it doesn't find something test, then it would return you -1. So we would specify that if it starts with an asterisk or ends with an asterisk, the leading or tailing asterisks are ignored. Well, the example shows words. Sounds complicated, but it might work. It sounds like it would work. The straightforward implementation would be just to start searching the same way like the normal function works, and then if you first just match until you find something that is blah. If you then see that you have an asterisk, then from there on in your matching function you are just looking for is there a t. If you find a t after blah, then you just continue with normal matching, like with the normal search function, until you encounter the next asterisk, and so on. But you could, of course, try to use existing find functions and split the string. Yeah, but then you also have like the situation. What if you have the question mark? So you would still need a specialized find function which only processes question marks, as there can be anything at this position. So I think ultimately it's not that beneficial to try to tokenize the whole expression based on the asterisks and then search. But whatever works. So you can implement as long as it works. It's fine. Okay, you know what? We can make it simpler. You can make a function which just does the matching. So which compares a given substring with a wildcard. And then you can use the match function within your search function to find whatever the match function matches. Then you don't need to think in then you don't need to care for both indices at the same time, because the match function, the way it works, it matches at the beginning and it ends at the end, and that's that. Yes. Well, the content will not work. Yes, you need the thing is, you would need in this function then one loop that starts with your string one. You should name one of the strings like uh, that you see which one will be tested with which one. So one, it has to be a normal string, and the other one should be a wildcard pattern. So call the first one string and call the second one pattern. Well, you only need to check whether it starts from the offset where you are at. So you don't need like to retry with I plus one, I plus two, etc. You just start if if the first characters match, if the second character match. So you need a loop, of course. Uh, and then now you just see which. Well, you should have two counters still, because you need one counter for the index within the string and one counter for the index within a pattern. Because in your pattern, it will be one loop but with two counters, because you will advance them differently. So let's think about a very simple test. May I write some test case down? Okay, so let's write our pattern blah stern loop. So this is what we supply as a pattern. And then what we supply as a string to match blah 1 2 3 loop. So when we start, both counters are 0, and we compare is b yes. Then we increment both counters by 1. Then we are at L. Then we see, okay, it's a L. Is it a L? Yes. We increment both by 2. Then we increment both, increment by 1, so we get 2. Then we increment again by 1, so we get 3. And then we see it's an asterisk, and it's supposed to be followed by B. So then we search if there is a B somewhere starting at the counter position before the end of the string, and if we find B, then we increment the counter for pattern by 1, but we increment the counter for string by 5. Actually by 6. No, sorry, we here increment by 2, because we already are matching for B, so we increment by 2, and here we increment by 6, and then we compare. Is it L? Yes. Is it U? Is it P? Is the pattern done? Yes, success. Is the pattern not done? Then the string ended before the pattern, return -1, or return false in that case. And we maybe should call it match wild match or something like that, so it's clear that it's a wildcard matching function. I would recommend for avoidance of potential bugs to not increment the I in the loop line, but really everything within the loop body, just to ensure that when you make somewhere a continue or so, you don't accidentally increment twice, just to be on the safe side. Once you have a working code, then you can look how you can reduce the amount of lines and etc. But for the starters, it's good to try to be as explicit with the code as one can. No, but then you would break out of the thing if the next character is not what you expect. You need within the loop to have a second loop which searches from the current index until the end of the string for the next character in the pattern. It should be. Well, you need an else before the if in line 158 so that you don't do both, because if you don't want if your string contains an asterisk, then you don't want that to cause any confusion. You pretty much just need to find the offset of pattern from P within the string starting at the current offset of I. Well, you need to make a loop which has a check like this, and within the loop would start at j like I, and then it would increment j, but the loop needs to be within the if of your pattern is asterisk. Yeah, here. At I, yes. Yes. String length. No, the whole thing is that you don't increment P because you just want to find the first match. And you also string should go from N and not from I. And you can have the yes, but you need the incrementation in the loop because you want to search at any offset after I for your pattern from P. So you don't need the N when you break, you just need the N++ in line 155 at the very end. Well, we are running out of time, so first question: do you want to continue next week for the last lecture and exercises, since we lost a day during December? Or are you already booked out with exams and stuff like that? Mm-hmm. Okay. Okay. How about the rest of you? Okay. 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 Then let's do that. Good. Then we continue next week. At least those of us that can. And we will see each other today evening for the lecture. Mm-hmm. Bye bye.